We live our entire lives on this planet, but how often do we actually stop and think about how it all works? Today, we're going to do just that. Think of this as a user's guide to planet Earth, and we're starting our journey from the outside looking in. Just take a second to look at that. A single, beautiful, vibrant sphere hanging in the quiet of space. That's us. That's Earth. It's the main character in our story, really. Every single thing that has ever happened in human history, it all happened right there.
And that really is the big question, isn't it? We know it's our home, of course, but what are the nuts and bolts? What makes this planet tick in such a special way that it can support all of us?
So first up, let's talk about why Earth is our just right planet. To really get a handle on Earth, you have to start with its address in the solar system. Turns out, location is everything.
You've probably heard this before, the Goldilocks idea. And it's honestly the perfect way to describe it. It's not scorching hot like Venus, and it's not a frozen desert like Mars. Nope, Earth is just right. And the biggest prize for being in this sweet spot? Liquid water. It's the absolute key ingredient for life as we know it. So let's break down the numbers, the vitals for our planet. For starters, it's ancient, about 4.5 billion years old. But the number that's really crucial for life is its position. We're the third planet from the sun, cruising along at a comfy 93 million miles away. That distance gives us the perfect amount of heat and energy to keep things, well, just right. Okay, section 2, a round blue marble. So we know where Earth is, but now let's zoom in and talk about what it is. What does our planet actually look like from a distance? And how in the world did we figure out its shape so long ago? You hear astronauts call it the blue marble, and when you see it like this, you totally get why. Every single color tells you a piece of the story. That incredible blue, that's our oceans. The white swirls, those are clouds, our weather in action. And those patches of brown and green, well, that's home. That's the land we live on. In this chart right here really shows you just how much blue we're talking about. Over 70%, almost 3/4 of our entire planet is covered in water. It's no wonder we look like a blue marble. We're fundamentally a water world.
But here's a wild thought. The idea that the Earth is round isn't new at all. We didn't need rockets or satellites to figure it out. Over 2,000 years ago, the ancient Greeks had it pegged, just by using their eyes and their brains. They measured shadows, they watched ships disappear over the horizon, and they saw Earth's curved shadow on the moon. Brilliant, right?
Now fast forward to today, and we've taken that same ancient curiosity and, well, put it on steroids. The science is called geodesy, and using amazing tools like GPS and a whole network of satellites, scientists can now measure our planet's shape, its gravity, even its rotation, with mind-blowing accuracy. And all this super precise measurement has uncovered a really cool little secret. Earth isn't a perfect circle. Because it's always spinning, it actually bulges out a little bit at the equator and gets slightly squashed at the poles. The fancy term is oblate spheroid, but you can just think of it as a slightly chubby sphere. All right, so Earth isn't just a static ball hanging in space. It's always moving in this beautiful, predictable dance. And this cosmic choreography, this constant dance of spinning and orbiting, is what defines our days, our years, and even our seasons. And this dance really has two main moves. The first one is rotation. That's the Earth spinning on its axis, like a top, once every 24 hours. That spin is what gives us day and night. The second move is revolution. That's our planet's year-long journey, or orbit, all the way around the sun. And that, of course, gives us our year. But here is the single most important detail in that entire dance. Earth doesn't spin straight up and down. It's tilted. It's tilted on its axis by 23.5 degrees. That number, that tiny little tilt, is the only reason we have seasons. It's responsible for everything from a summer day at the beach to a winter blizzard. Which brings us to a really good question. If we stay roughly the same distance from the sun all year, why do we have seasons? Why isn't it just warm or cold all the time? And the answer is all in that 23.5-degree tilt. So take a look at this diagram with me. It shows exactly how it works. When the northern hemisphere is tilted toward the sun, we get the sun's rays more directly, more concentrated. That's our summer. At the very same time, the southern hemisphere is tilted away from the sun, so it gets less direct light and experiences winter. Then, 6 months later, as we orbit to the other side, the whole thing flips. It's such a simple tilt, but it changes everything for us on the ground. All right, we've seen Earth from way out in space, we've tracked its dance around the sun. Now let's zoom in one last time to see how everything on the surface, the land, the water, the air, and yes, all of life, works together as one big unified system.
You know, for the longest time, science looked at all these things, land, air, water, life, as totally separate subjects. But what we understand now is that they are all deeply connected. They're four parts of a single, giant, interconnected system, and they're always affecting each other.
And that's the whole idea behind what we now call the Earth system. The big takeaway is that nothing on this planet happens in a bubble. A change in the air affects the oceans. A change in the oceans affects life on land. You get the idea. It's all one giant, amazing, interconnected machine.
Think about it like this. It's a constant loop. A volcano erupts on land, and it pumps gas into the air. That changes the air, which helps form clouds. Those clouds then drop rain back onto the land. That water gives life to plants and animals, like us. And we, in turn, breathe that air and drink that water. See? It's a circle. It's all connected.
So, finally, let's talk about the big takeaway. Keeping an eye on Earth. Why does all this stuff matter? Why do we put so much effort into studying a planet we think we already know inside and out? Well, the reasons are incredibly practical. I mean, think about it. From space, our satellites are like doctors, giving the Earth a constant checkup. They help us see how our planet is changing. And that data is absolutely vital for everything from forecasting the weather and tracking hurricanes to helping farmers know when to plant and public health officials track diseases. And in the end, it all boils down to this one simple, powerful idea. This isn't just about cool science facts. The more we all understand about how our home planet works, the smarter the decisions we can make about living on it. Knowledge really is power. Here's the thing. Our planet has never stood still. It's always changing. But now, humanity is a major force driving a lot of that change. So that leaves us with a huge question, a question for all of us. Now that we know how it all works, what decisions are we going to make for the future of this amazing, one-of-a-kind planet we call home?